For this video, we will be locating the vertices and the foci on a hyperbola. So remember that when it's in standard form, it's going to be x squared over a squared, so this is the a squared, minus y squared over b squared. So this is always a squared and this is always b squared. It's not the same as an ellipse where a squared is bigger, so it's always, the first one is a squared. So since a squared is under the x, then we know that we are going to have a hyperbola that is going to open to the right and to the left. So this one will have a center at 0, 0 because it's just x squared and y squared. So the center is going to be here at 0, 0. And a is going to be the distance to the vertices. So here a squared is 1, so a also equals 1. So the distance from the center to the vertices will be 1. So we'll have a vertex over here at 1, 0. So we'll have a vertex at 1, 0. And then we'll have another vertex over here at -1, 0. So the hyperbola is opening to the right and to the left, and here are the two vertices. Now we are going to find the foci. So the relationship here is c squared equals a squared plus b squared, and this chart can be found on page 632 of your textbook. So c squared is what we're going to solve for, so c squared is going to be equivalent to a squared, which is 1, plus b squared, which is 4. So c squared equals 5, and c equals the square root of 5. So on the hyperbolas, the foci are located over here, also on this main transverse axis. So we'll have a foci there and a foci there. So the ordered pairs for the foci will be located at square root of 5, 0, and negative square root of 5, 0. Okay, let me work out one more example. On this one, we're going to write the equation. So on this one, we're going to write the equation for the hyperbola. So on this one, we will be given the vertices and the foci. So for this particular problem, the vertices are going to be located at positive and -4, 0, and the foci are located at positive and -5, 0. Okay, so if we look at where these are located on the x-axis here. At 4, 0 is a vertex, and at -4, 0 is a vertex. So the hyperbola is going to open to the right and to the left. So the standard form for a hyperbola opens to the right and to the left is x squared over a squared minus y squared over b squared, and that equals 1. This is a, so a again is the distance to the vertex, so a is 4, and c is the distance to the foci, so c here equals 5. So we will need to solve for b so that we can write that equation. So we need to figure out what b is, or basically b squared. So again, we're going to use the relationship of c squared equals a squared plus b squared. So c squared is 25 equals a squared, which is, so if a is 4, a squared will be 16, plus b squared. So go ahead and subtract 16 from each side. So b squared equals 9. So b squared equals 9, and a squared equals 16. So now we can substitute in and write the answer. So the equation is going to be x squared over a squared, which is 16, minus y squared over b squared, which is 9, and that will equal 1. So there will be your equation.